So I guess we will jump right into it and let people join as they join. But thank you guys for coming and being with us and giving some background on your code to the community. So the way this works, we've already gone over it, but I'll just give you a quick reminder. We do this for about half an hour, so we'll go till about 10:30 Eastern. We do about 20 minutes for the code walkthrough, and then about 10 minutes for the Q&A. If there's no major Q&A, then we'll just let you keep presenting if you still have stuff to go after that 20 minutes until there is either a question or the 30 minutes pop. But other than that, I will pass it right over to you guys and let you do your thing. Feel free to share your screens and yeah.
I'm going to be starting in the Alchemist V3, which is the main CDP contract. I think important things to mention for this contract is just sort of how, like, we have our basic actions like deposit, collateral, withdraw collateral, mint debt from your collateral. We have the burn function, which allows you to pay off some of your debt using synthetics. We have the repay function that will allow you to pay off your debt using yield-bearing assets. Got our liquidation stuff. So those are all like the basic things, but I guess the most important things to think about is like this redemption system that we have within the transmuter. Actually, I'm going to switch over to the transmuter real quick because you kind of need that background. So basically, right, the transmuter, you'll deposit a synthetic asset, and over time, you'll get, supposedly, you'll get a one-to-one trade back for collateral assets. I say supposedly because there are other factors that'll affect how much you get, but in optimal conditions, you'll be getting, one-to-one value, collateral value to debt over time. But what's actually happening in the code when somebody makes a transmuter position, we have this create redemption here. We're using a data structure called the Fenwick tree, which is kind of like a pseudo tree that allows us to do range queries and updates for like a pseudo array, but keeping it low time complexity. So it runs on chain. But essentially, when you create a transmuter position, what's happening is it's separating it into blocks, right? Say if you have a transmuter position over the next 100 blocks for 100 tokens, it's going to store into this tree one token for the next 100 blocks. And these sort of stack. So if somebody halfway through that 100 puts another 100 in, then the next 50 will be 2 per block, and then the next 50 after that will be 1. So it kind of creates this system where we know every single block exactly how many funds we need to take from the Alchemist collateral to fulfill these transmutations. And then so going back to the Alchemist V3, when any user does an action that changes their debt, whether it be a mint or they repay, we always call this function sync. And sync is what actually stores like what your current debt and everything is into your CDP. So anytime that a debt changing action happens, we call this function sync. Let me pull it up here. This is the meat of what the code is doing. So essentially, when somebody syncs, right? Or before we sync, I'm getting ahead of myself. We earmark. So let's say we know the time that we last earmarked, and then we know the current time. So we can say between these two times, how many tokens do we need to fulfill like what the transmuter requires at that time. So it will query the transmuter, and it will say, okay, it's been 10 blocks since the last like major earmark update. So how many tokens do we need to set aside from users' collateral in the Alchemist within these 10 blocks so that we can send them to the transmuter when somebody comes in and like finally claims their transmutation position. So it will check that, and then it will sync a user's account. Like users kind of have these ambiguous CDPs that aren't, the data is not constantly changing in there, but we can kind of infer what your current debt is, what your current collateral is by using these scaling weights. And this is kind of the main thing that the Alchemist contract is doing here is it's using three different scaling weights. We have one scaling weight that represents like how much debt gets earmarked with each earmark call. Earmark just being like querying the transmuter. So we have one weight that is how much debt is being earmarked. It's the ratio of how much debt is currently being earmarked to the total unearmarked debt. We're also storing another weight, which is the amount that gets redeemed out of that earmarked amount. And redeemed amount is when somebody in the transmuter finally say their transmutation time is over and they go to claim their, one-to-one redemption. That's when the funds actually get moved out of the Alchemist. So we sort of have these we have like regular debt, we have earmarked debt, which is debt that's sort of been flagged for future redemptions but is still in your account. And then we have redeemed debt, which is when somebody actually claims from the transmuter, then that debt gets removed from your account, and also an equal amount of your collateral is also redeemed, because that's like, your debt goes down and that collateral that gets redeemed gets sent to the transmuter so that that user can, get their swap off at the end. We're also storing a third weight, which is used to represent the collateral. The collateral changes price over time. So in order to sort of lock in the price when a redemption happens, we're using this third scaling weight. And that also takes into account fees. When a redemption happens, a flat fee gets taken off the top, and a little extra collateral is removed from every user's CDP to cover that fee. We're using a library for this called position decay. I'm not going to waste time like getting into this right now. It's a lot of super low level bitwise operations and whatnot. But essentially, what this is doing is these ratios, right, that we're taking of, say, earmarked funds, or how much is being earmarked versus like a total unearmarked. That gives us a percentage. And as these percentages stack over time, they sort of trend towards zero, and that will eventually lead to underflow and loss of precision. So basically what this position decay library does is it takes that fraction and it puts it into a logarithmic space. So turning like a decreasing number into a linearly increasing number just by taking the logarithm and then unwrapping back out. So at any time, if you see like in the Alchemist, let's see, yeah, in the earmark function, like if you see position decay, like weight increment, then it's taking a log of like whatever this weight is here. This is going to be the numerator. This is the denominator. It's taking the log of that, and then it's adding it to this global earmark weight. So this now becomes like a linearly upward scaling value. And if you see, let me see. And then we check these weights against the user's individual. Like the weights are based off a global value, and the user's individual CDPs are going to be based off their individual account value. So when you take these weights and you apply, like, they are based off a global value, but when you apply them to individual positions, it will tell you like what portion of that user's debt has been paid off and what portion of their collateral has been redeemed and any fees accrued. So you get this position decay scale by weight delta. That's essentially doing an exponent, the opposite of log, and converting the number back into like a regular position value. So the flow is kind of like if you mint more debt, it's going to query the transmuter, find out how many tokens it needs from the last query to now to fulfill this redemption. And then it will sync up your account. with whatever like the current block, what your CDP will be. We have another function called calculate unrealized debt, which is basically the same as sync, but it's not writing to the contract storage. This is how like someone would know how much available collateral they could withdraw without like violating the LTV. Or like say you go on the UI to look at your account. This function can be used to determine what your account would look like if you synced, but it's just not actually writing storage data. So it's doing a very similar thing here. It's querying the transmuter just like sync, but it's not actually like writing it to your account. And that's obviously just to keep it a view function and make it free to see what you currently owe and what your current balances are and stuff. Trying to think what else would be relevant here in these last 2 minutes.
I can
We
add
have
one thing.
another.
Should have talked about
Yeah.
quick. It should be noted that Alchemist is designed to accept a single collateral token. Where if anyone's familiar with Alchemix v2, there are like multiple different yield strategies. In Alchemix v3, each Alchemist transmuter pair accepts one yield token. And the idea is this will be a yield token, kind of like in the style of Urine v3 or Euler Earn or something like that. Most likely it'll be Euler Earn, but it'll be a managed vault that the Alchemix DAO owns, made up of multiple yield strategies. So this managed vault does not exist yet. That's kind of the next project to make Alchemix v3 come together now that we have the core contracts. But anywhere you see reference to the meta yield token or the MYT, that's talking about that future single collateral, single yield token that's going to be deposited in the Alchemist. So it's probably easiest to think of it as like an Alchemix DAO managed urine vault, morpho vault, Euler vault, like something like that. But it's more of a generic thought at this point, whereas in the future we will also have an audit contest for the meta yield token and its relation to Alchemix v3. But that's essentially what the meta yield token is referring to right now.
One more thing, aside from the position decay library, which is for the weights in the Alchemist, we have the staking graph library, which is the Fenwick tree implementation for the transmuter. Quick explanation of this. For doing Fenwick tree stuff with ranged updates and queries, you need to have two trees. And so what we've done here is we've actually just taken we've made one tree and we've split the bits 144 to 112. And so one tree is stored in like the first bits and one tree is stored in the second bits to combine them into one tree, which makes it a lot cheaper. I think that we're putting this in scope. So if this is within anyone's skill set, like feel free to look at this. There are some rounding behaviors and things that it might be good to look at.
And Scrub, everything in source is in scope, right?
Yeah, it should be.
Right. Yeah.
Yeah, I guess it is question time. That was probably pretty confusing. It's pretty hard to truncate like an explanation of all that stuff into 10 minutes, but hopefully you guys got something out of that. Yeah, let me know if there's anything that you want to clarify or.
Yeah.
And also feel free to tag me and Scrub in Discord if people have like basic questions. Obviously you can also tag in the Cantina platform for like bigger questions, but if you're literally just trying to find like where something is or be like a very basic question, we also are active in Discord.
Yeah, I'll be on all day if anyone wants to ping me with stuff.
Awesome. So yeah, guys, we have about 9 minutes left. If you have any questions, throw them in chat for this stage, and we will get right to them. I do see somebody's typing right now, so we will give them a second, and we'll get it answered. Otherwise, let's see. What is the main profit incentive for Alchemix? Where does most of the money come from?
Yeah, I can answer that one. That's going to come from two places. One, that meta yield token I talked about, that's going to have its own fees on it as the DAO will be managing it. And then having the utility of that being the only collateral in Alchemix makes it like a desirable yield token to utilize. Within Alchemix, there There are a couple places fees come from or can come from, but the main one we plan to use is as a borrower when you get redeemed. So when you have that collateral and debt both decrease, you'll have your collateral decreased a little bit more than the debt. And that there's like a fixed percentage of collateral that we also take as fee. I think the plan is to set it as like 0.5% or something. Um, so yeah, we're basically taking a fee whenever people get redeemed. We aren't taking a protocol fee for liquidations because we don't think protocols should profit from liquidations because you should be trying to make sure those don't happen as much as possible. And then there are ways to take fees on the transmuter side as well, but it's not something we really anticipate needing to use. So yeah, mostly taking fees from borrowers. And I should note I don't know if we ever said the words redemption rate. Those may show up in the code or the docs or something, but essentially the rate at which all of the transmuter claims are coming due is going to create like a rate of deleveraging, which we call the redemption rate. So if you have like some amount borrowed, a redemption rate of 100% would mean in 1 year, your full debt would be cleared and an equivalent amount of collateral.
Yeah, there's no variable in the code called redemption rate. Instead, in the code, that's kind of inferred. We're just using, we know like from one time period to another how much needs to be redeemed. And then from that, we can infer like what the rate is. But yeah, there's not going to be like any actual like percentage rate stored in the contract
Yeah.
for that.
The secondary thing that users experience that basically indicates the rate of deleveraging that people are experiencing.
Antonio asked, "Are redemption buffers MEV safe and non-drainable?"
I don't believe we're using a buffer.
We have
Kind
a
of just gets pulled out exactly at the time of redemption. And
Yeah, I think there's only one scenario. So pretty much all the time the collateral is either owned by the borrower or it's owned by the person in the transmitter. So there's very few situations where the protocol actually owns these funds. Um, I think the only scenario, Scrub, correct me if I'm wrong, but I think if a liquidation occurs, then or if someone repays their debt with the yield token, that's kind of triggering an early redemption. And in that case, I think the yield tokens get held in escrow for a period of time.
yeah, they
In
sit in the transmuter. Any funds that are repaid by the user will that aren't because like so the funds don't move till a redemption, right? So if somebody repays and burns early, it's gonna sit in the transmuter, and then when someone goes to claim their redemption, it will pull from that amount before it pulls from users' collateral in the Alchemist.
Awesome.
not
Looks
sure
like.
if that yeah, not sure if that directly answers the question, but feel free to rephrase with that context, Antonio.
And then Barachi is back. He wants to know, what is the main cause for concern for the protocol, as in the source where the protocol is worried about possible bugs, such as a place where heavy math is a cause for concern or some kind of external integration.
So that's going to be the two libraries, the position decay and the staking graph. We've looked a decent amount at them, but like we're I guess a concern with that is just rounding behavior. Over the long term, we kind of sort of try to do a central rounding solution where we're not really always truncating or always adding one way at the end every time. So that way it's like minimized. But yeah, there's definitely room for stuff like that in there.
Oh, that would be the position decay library and the staking graph.
In the staking graph, yeah.
Yeah.
And just wherever those are used within the Alchemist, they're going to be used within like the earmark function and within the redeem function and like syncing and earmarking and everything. So
Yep. And then I would say also looking at the vaults for liquidations are another area of focus just because those were added kind of late. Those are pretty basic. Again, it's just to help fund liquidators if there's not enough collateral within the system itself. And related to that, I would say just ensuring that liquidations play nice with the earmarking system, which I believe we have covered, but just like Alchemix is a bit different in that like the first obligation of the system is two people in the transmuter. So you need to make sure that things like liquidations and stuff are not creating scenarios where the transmuter cannot actually fulfill its obligations to people who are trying to convert through the transmuter.
Yeah, definitely a good spot to look at is when a user's account gets synced or if the calculate unrealized debt function is called, like are these actually producing the values we expect, or is there some kind of like divergence over time?
Yeah. Ratio, it has gone through an audit for whatever reason that didn't make it into the Cantina scope, but it's being added ASAP. It went through a Spearbit audit, I think 2 rounds. So it went through a full audit with 2 researchers and then another solo review from Ricard, who's also helping triage on this competition, I believe. So those should be shared, and we'll try to drop those in the chat whenever those get added to the scope. So that should be helpful for a lot of context for people. There's another question: is liquidation fast enough to stop depeg exploits? Not so. One thing to note is the intent in V3, Alchemix V3, is to use fundamental oracles. So this would mean like if staked ETH is or wrap staked ETH is a yield strategy, we're pricing wrap staked ETH based on the amount of ETH you can withdraw, even if you can't withdraw it right now, rather than the market price of ETH. And so that means if the price of a staked ETH flash crashes, the system is temporarily under collateralized. However, as long as that ETH still exists in the staked ETH contract, there is still full collateralization. It just may be a delay in realizing that collateralization. The main downside of that is that if there is a depeg of a yield strategy on the open market, that can create a situation where the price of the synthetic assets are going to depeg as well. And that is expected behavior. So it essentially means we can't integrate super long tail risk yield strategies into Alchemix v3, like yield strategies that could have a very long lockup in accessing your assets, because that would just mean the price of the synthetic assets is going to be kind of low, which would be annoying. And to be clear, these synthetic assets are not made to be one-to-one price. They're made to be very close to one-to-one, but by nature, the product is not a one-to-one peg like it is with a stablecoin. The product is that these synths are like an earning opportunity, and these synths are a way to access future yield, which means they, outside of maybe like rampant growth and stuff, they'll probably be slightly below one-to-one in typical behavior for their pricing.
Yeah, and the more below 1-to-1 they are, the more profitable they are to
Yeah,
enter the
'cause I mean,
transmuter.
yep, because your transmuter is, say you have like a 3-month timeline on the transmuter, what Al acid is 0.98, then you're getting a 2% arbitrage over 3 months essentially. So 8% yield, for example.
Sweet, sweet. Well, that looks about all the time we had for today. Big thank you, Scrub, Overqualified, for coming out, hanging out with us. For those of you guys that just joined or watching this on YouTube, they did say they will be hanging out in the Discord. So if it's a quick question, you just need help finding something, feel free to ping them in the dedicated competition channel on Discord. Otherwise, use Cantina pings on the website. Keep the more in-depth conversations there. This will be uploaded to YouTube later today, but just a reminder, $50,000 prize pool goes from May 1st, which was yesterday, to May 15th. But yeah, I think we will call it right here. So thank you guys for coming in and helping out with the community today. Everybody,
Awesome. Thanks a lot, man.
Thank you.
Yeah, thank you. Everybody have a good afternoon.
Bye.